Hi, thanks for coming. So today we will talk about data pre-processing. So due to their usually huge size, often several gigabytes or more, and their probable origin from various heterogeneous sources, the real-world databases of today are highly susceptible to noisy, incomplete, and unreliable information. So why is data pre-processing important? So data have quality when they fulfill the unintended usage criteria. Certain criteria, including accuracy, completeness, validity, timeliness, credibility, and interpretability. So major data pre-processing tasks and techniques. So therefore, a useful pre-processing step is to run the data through some data cleaning routines. Data cleaning routines work to clean the data by filling in missing values, smoothing noisy data, identifying or removing outliers, and solving inconsistencies. Data reduction obtains a reduced data set representation, which is much smaller in size but provides the same or nearly the same analytical results. Strategies for data reduction include the reduction of dimensionality and the reduction of numbers. Data encoding schemes are used to achieve a simplified or compressed representation of the original data through dimensionality reduction. Examples include techniques for data compression, such as principal components analysis aka PCA and wavelet transforms, subset selection of attributes such as deletion or obsolete attributes, and creation of attributes where a limited set of more valuable attributes are extracted from the original set. In the numerosity reduction, data is replaced by alternative smaller representation using parametric models such as regression and log linear models, or non-parametric models such as histograms, clusters, samplings, or data aggregation. Normalization, data discretization, and concept hierarchy generation are forms of data transformation. Discretization and the generation of concept hierarchy are powerful tools for data analysis, allowing multi-level data analysis. So data cleaning. So data from the real world appears to be incomplete, noisy, and incoherent. Routines for data cleaning, or try to fill in missing values, smooth out noise while identifying outliers, and correct data inconsistencies. There are a few methods to fill up the missing values. First, ignore the tuple. Second, fill in the missing value manually. Third, use a global constant to filling in the missing value. Fourth, use a measure of central tendency for the attribute such as the mean or median to fill in the missing value. Fifth, use the attribute mean or median for all samples belonging to the same class as the given tuple. Sixth, use the most probable value to fill in the missing value. So there are few data smoothing methods on noisy data. The sorted values are distributed in a set of buckets or bins. Binning method smooths a sorted data value by checking its neighborhood, aka values. Multiple linear regression is a linear regression extension involving more than two attributes and fitting the data to a multi-dimensional surface. Linear regression involves finding the right line to match two attributes or variables in order to predict the other attribute. So outlier analysis can be identified by clustering, for example, where similar values are grouped into classes or clusters. Intuitively, values outside the set of clusters can be considered outliers. So we'll be looking at methods to tackle missing data and data smoothing so far. Missing values, noise, and anomalies lead to information inaccuracy. Discrepancies can be caused by multiple factors, including poorly designed data entry forms with multiple optional fields, human data entry errors, deliberate errors such as respondents who do not want to disclose information about themselves, and data decay, aka, or we call it as outdated addresses. So certain examples of inconsistencies include errors that record information and software failures in instrumentation systems. So, how do we detect discrepancies? As a starting point, use any information about the properties of the data you may already have. For example, what are rich attributes, data type, and domain? For each attribute, what are the relevant values? So the basic explanations of statistical data are useful here to catch patterns in data and to recognize anomalies. There are variants of methods for analyzing data. Tools for data auditing recognize inconsistencies by analyzing the data for finding rules and relationships and identifying data that breaches such conditions. So data integration. In data integration, redundancy is another important issue. If it can be derived from another attribute or set of attributes. An attribute such as annual revenue, for example, may be redundant. So correlation analysis can identify certain redundancies. So based on the available data, this study will calculate how strongly one attribute implies the other, given two attributes. So there are few correlation analysis methods. So correlation test for nominal data, so chi-square. Second, correlation coefficient for numeric data, and covariance of numeric data. So okay, you can find more details on the description below. So data reduction. So data reduction techniques can be applied in order to obtain a reduced representation of the data set, which is much smaller in volume, but which keeps the integrity of the original data close. That is, analysis should be more effective on the reduced dataset while generating the same or nearly the same analytical results. So data reduction strategies include principal component analysis, PCA, attribute subset selection, parametric data reduction, regression and log linear models, histograms, clustering, sampling, and data cube aggregation. So data transformation and data discretization. So the data will be transformed or condensed into forms appropriate for analysis in data transformation. So data transformation methods are as follows: smoothing, attribute construction, aggregation, normalization, discretization, and concept hierarchy generation for nominal data. So using the neural network backpropagation algorithm for classification analysis can help speed up the learning process by normalizing the input values for each attribute calculated in the training tuples. So normalization data attempts to give equal weight to all attributes. So there are many methods for data normalization include minimum maximum normalization, z-score normalization, and normalization by decimal scaling. So binning is also used as a discretization method for data reduction. For example, attribute values can be discredited by applying equal width or equal frequency binning, and then replacing each bin value with the mean or median mean, as in bin mirror smoothing or bin's median smoothing respectively. So thank you for watching, and don't forget to like this video. and subscribe.